Give it just another minute. See if we can get a couple more people in. It's looking pretty good. Okay, so that is 16 out of 18. So we'll get started. I think if you're not on mute, put yourself on mute. Just because every little sound in your world will amplify, and then we'll end up hearing everybody's typing and everything. So just make sure you're on mute. So it's nice to meet you all. My name is Candace Henderson. I will be your instructor for Chem 092. So this is somewhat equivalent to high school chemistry, but it's under the assumption there are that it's like college level expectations, right? So you're just going to want to be making sure you're turning things in on time and stuff like that. Full disclosure, my husband and I and my daughters totally got COVID last week, along with I feel like everybody else in North Carolina, and we're doing fine. Definitely on the mend. I couldn't smell a dead horse if it was in my kitchen, and you could probably poison me with Drano, and I would have no idea. But outside of that, I'm feeling okay. So if this first week, if you're sending me an email and it's taking me just a little bit longer to get back, I'm super sorry. It's really because I have both of my kids on top of working. All right. So you can be patient with me through this week. Then we should be good. So let's, I'm going to go ahead and share my screen. Really quick, let's talk about the setup here of your Zoom page. So if you look down at the bottom bar, you should see a mute button. Your mute button should be on. So there'll be like a red slash through it. Stop video. So look, I have totally been in Zoom meetings before in my bed, in my PJs with the camera off. I understand. It happens from time to time. But if you can have your camera on from time to time, it is helpful for me when I'm lecturing to you guys because I can see your faces or some people's faces and see like, okay, they're getting this or you're not getting this. Participants so that you can see who else is in there. Share screen is something that I will be using. Trying to see. So the main thing is the chat. So I want you to be able to type in the chat. So if you can just say, hey, what's up in the chat, you'll find it on that bottom bar, just so that I can get an idea that you are, hello, hey, what's up? Awesome, cool. There are a couple options. You can see that you can send it to everyone or you can send it privately. So if you have like a friend in the class, you could send them a message privately. I would recommend not doing that, okay? Just because there have been times people have tried to send private messages that ended up getting sent to everybody. So maybe just text your friend if they're in the class. Otherwise, we'll leave that for messages for everyone. If you want to send me something privately, you can. Again, if it's something that's really sensitive, you may just want to send me an email, okay? FYI, also besides the fact that I can't smell and taste anything, I have total COVID brain. So my brain is working at like 65% of the capacity. So bear with me there as well. Okay, so we're good with the chat. So I'm going to share my screen with you guys. And we're going to take a look at Moodle and the syllabus just so that we know where everything is. So if you haven't logged into Moodle yet, you'll want to do that sometime today. Our class is this guy right here, Chem 092 OT1. So all the goodies are in there. That's where you'll find really mostly everything outside of your text and your lab manual. At the top here, I have a section for notifications. I'll try and update that weekly. Delaney, check in with me at the end of class and we can try and figure that out, okay? So where was I? Oh yeah, so notifications. So I'll try and update that weekly, just letting you know, hey, like big due dates, I'm not gonna put down, you have a homework assignment due, but I will put things like your test is coming up. So make sure you check in there. My email is right up at the top so that you can always find that quickly. And then the syllabus. Now the syllabus is going to be your best friend when it comes to these online courses, because it's where, you know, it lets you know where everything is due and when they're due. So we'll do it in read only. All right. I'll close some of you guys out here. Okay. So here's the syllabus. We're kind of going to hop back and forth between these two. Hop over to the syllabus as far as how the setup of this class is going to go. We run through the second week of May, but that second week of May is really just for the final. So the first week of May is kind of the last like lecture class day. We will be meeting synchronous for live Zoom classes on Mondays and Wednesdays from 9:30 a.m. to 10:45 a.m. Excuse me. I do record these Zoom meetings. So if you happen to miss a Zoom meeting, you can catch up. I will post those on YouTube. Where do you find those? Let's go back over here to our Moodle page. If you go into the section here where it says Zoom meetings and lectures, so the login, this is always the link that you'll use getting into this meeting. It's the same link. You can find it here, you can find it in your email. The lecture videos, if you click on this here, it'll take you to my YouTube channel, Candace in Chemistry, and I will post the videos up there by the end of the week. So I wouldn't recommend missing lectures regularly because you can't ask questions watching the Zoom video later, but it is a nice resource because I know this is like a crazy time and we're all just trying to do the best we can. So if you have to miss a lecture here and there, that's a great place to check up. Or if you didn't quite get something and you want to rewatch it, you can do it there. All right, so let's see. As far as the labs are concerned, labs are asynchronous. That means that you're going to complete those on your own time. You will need the lab manual, which I don't know if I have a copy of it on me. I think it might be in my office. It will look something similar to this. This is the 151, but it'll look something similar to this. It is a printout that AB Tech actually does. So it only costs you like $5. You will need to have that. You can't get it on Amazon or anything like that. Those labs will all be done on your time, but they have specific due dates. Okay, so let's look at what we've got for the labs. So if you go onto the Moodle page, you'll see this section here, which is laboratory resources and laboratory submissions. There's two things that you're going to want to look over at first. This one is how to submit a lab online. So if you haven't done this yet, you're going to want to watch this video. It pretty much tells you how you're going to submit the lab. Each of these are the different labs that you are going to need to turn in. You don't click on this to fill out a lab. You click on this to submit your lab. So you will take your lab from the lab manual, you'll fill it out, you'll take a picture of it, or you will scan it, and then you will put it into a PDF form and you will submit it to me here in the given section. Please submit your labs one page at a time, as opposed to trying to cram like 6 pages on one page, because then I have to pull out a magnifying lens to read your guys' labs. So I don't want to do that. Submit it as a PDF. It's easier for me to grade when they're PDFs. How do we do the labs? Because we aren't meeting in person. Well, if you click on, not that guy there, but if you click on this link at the top of the lab section that says all lab procedures and data here, that is going to be sort of your information. These are all going to be what we call dry labs, because you can't run them experimentally in the lab setting right now. So you'll click on these and it'll give you the data that you need for certain parts of the lab that, you know, like this experiment happens, how much of this is produced, we'd give you how much is produced as opposed to you running the experiment. There's also videos. So these are going to help you get through those labs. So you'll use this. You'll fill out the lab in your lab manual. You'll take a picture and or scan it, and then you will submit it to me by the due date. The due dates are here. The due dates are also on the syllabus. I've sort of put due dates everywhere, so hopefully they're accessible. The first experiment is due not this Sunday, but next Sunday. Okay, so you've got 2 weeks to play around with it. I wouldn't wait until Sunday night at 11:52 to try and submit it, because if you can't get it to work, I'm not going to be answering emails then. So I would try and do it a little bit earlier than that. Sorry. All right, so that's all the labs. If you want to work ahead, you can, but I won't answer questions on labs that we haven't gone over yet. So if we're like talking about measurements, I will help you with the measurements lab. Sometimes I get really overzealous students and they're already on the nomenclature lab and they're like, I have questions on the nomenclature lab. I'm not going to answer questions on the nomenclature lab because we haven't lectured on it. And then I end up having to lecture on things 2, 3, 4, 5 times. You may be like, I'm not that overzealous. I won't be working that far ahead. So at least be getting them in week by week. Along with these labs, we have something right after it, which are your laboratory weekly quizzes. These quizzes correspond directly to the experiment, okay? So this is a measurements experiment that's due on 1/24. There's also going to be a quiz that's due on 1/24 on measurements. Make sure you're getting those done as well, all right? So every time you turn a lab in, mentally be asking yourself, did I do the quiz as well? And you'll find the quiz right underneath it. Let's pull this back up. Just kind of ping pong back and forth. Our meeting location is online Zoom. We won't have any contact. You definitely don't want contact with me right now. But we're planning not to have any contact for the semester, but I can always have private Zoom meetings with you guys one-on-one, you know, I'm flexible. You do have a couple prerequisites, DMA 040 and DRE 096. If that hasn't happened, let me know. No co-requisites. You don't have to take anything in addition to this. What is required of you to have? So you will need the textbook, Introductory to Chemistry, and then really the important thing is that you have the Mastering Chemistry access code. So with each textbook, you get this access code that lets you do your online homework. You can buy the access code without buying the textbook. If you do that, that is up to you. Have I ever taken a class in college before without buying the textbook? I have. That may work for you. If you are having, if you need additional resources though, it's probably good to have the textbook. Like if chemistry isn't your thing, you might want to have that. Important thing though, is that if you buy a used version of the textbook, it doesn't come with a Mastering Chemistry code. You'd have to buy the Mastering Chemistry code on top of it. So make sure you can get that. The Mastering Chemistry Access Code, yeah. Scientific Calculator is recommended. So that's a TI 83, 84. Those are the bigger ones with the bigger screens where you can sort of easily plug in calculations. Look, if you don't have a TI 83 and a TI 84, and this is like the only class you're gonna take where you'd need something like that, you don't have to go out and buy a $90 calculator. You can get by with a regular calculator. It just might be a little more cumbersome with some of the exponent numbers, calculating them in. You need the capacity to scan documents, or you can use your phone to take a picture and submit it as a PDF. As far as my information, there's my email again, office hours Wednesday, 11 to 12:30. Don't get freaked out if that doesn't work for you. I can meet you other times, all right? My preferred communication is email. That's really the only way. I will try and get back to you within 24 hours. If you don't hear from me within 3 days, you can reach out to my advisor or my head, Matthew. But if you haven't heard back from me in 24 hours, just say, hey, any updates? And it'll bump it to the top of my inbox. Sometimes my inbox can get a little crazy. So course objectives, you can go through this on your own. You're going to need to go through the syllabus anyway on your own. And then I'm going to pop back over here in Moodle. You need to verify the syllabus. So up at the very top, right underneath the syllabus link, there's a syllabus verification. It's nothing freaky. It's literally just saying, yes, I've read the syllabus, but I need you to do that by Sunday. That will give you like credit for the census period. So I'm not making you guys turn an assignment in, but somehow I have to say that you've like shown up and done something. That's going to be your done something to stay in the class. If you don't verify that, you could technically get booted out of the class. So please just make sure to do that by Sunday. I mean, if you want, you just do it right after this. Okay, so evaluation criteria, you have quizzes, you have homework, you have tests, and you have a comprehensive final comprehensive meeting. It covers everything. So how we break it down, pretty standard, A 90 to 100. These are in 10 block increments or 10-point increments. Gets a little bit gray around that like 89, even like 88.5, right? It's like, oh, it's so close to an A. Well, you know, I've got room to play with that. So if you've been in the lectures, if you've been attentive, if you've been turning things in on time, you've been communicative with me about what's going on, how things are going, that 88.5 can turn to an A really quickly, all right? If I've never seen you ever, I have no idea who you are, you've just submitted labs, that 88.5 is probably gonna stay a B. So, you know, a smile and showing up can do a lot. As far as how the class is broken down, there are lecture tests. There are 4 exams that are 45% of your grade. There is something called a grade replacement policy. So if you miss an exam, or if you bomb a test, you just get like a 30% on one of your tests. If your final exam is better than that lowest test grade, it will replace the lowest test grade. Okay, so let's say you got an 80%, an 80%, an 80%, and then you got a 20%. And then on the final, you ended up getting an 80%. Well, that last 20% will get swapped with the 80%, and now you have 80s across the board, all right? I don't do it the reverse way, so if you do worse on the final, I won't take your lowest grade and swap it with a lower grade. Final exam, 15% in addition to replacing a grade. The lab is worth 25%. That includes the data sheets that you're going to turn in, which are 17.5, and then the online quizzes, which are 7.5. So this is a great place to get your grades up. Tests, I think, always tend to be the most challenging thing for students, but if you do well in the labs and in the homework, you can end up with a surprisingly good grade. With the labs, if you turn a lab in blank, it makes it really easy for me to grade. I just go 0, 0, 0, right? So make it hard for me. At least put an educated guess in there. And I will give you the benefit of the doubt. It doesn't mean I'm going to give you 100% just because it's filled in, but if you're filling it in with educational and thought-provoking answers, I will try and give you as much credit as I can. Then we have homework, which is on mastering chemistry, and we'll talk about that in just a minute and where you can find that. That is 15% of your grade. This is always the part where people are like, I want to claw my eyeballs out. Do the best you can on this. Again, this will, as long as you're doing it, you're turning it in on time. I can see how much time you've spent on it. So you can't just go through and click A. You've got to actually try. I will give you the benefit of the doubt again with that. I'm not going to let the mastering chemistry, like let's say, you end up with a 75 on the mastering chemistry. You've done every assignment, you get a 75. Everything else is putting you at an A. I'm not going to pull your grade down to a B because of the homework. Okay. But with that being said, if you don't do the homework, then I will just keep it true and you will just get whatever grade it is that you got on it. So make sure for participation and census stuff that you get that syllabus verified. All right, going through here. Here's all the chapters we're going to go through. We don't go over every chapter and we don't go through them in perfect order. So don't get freaked out if we jump around a little bit. Lab policy. So you will need to be able to scan your labs into the Moodle page. Any late labs, it will be a 10% reduction per day. So just turn them in on time. It always sounds so easy, right? Just turn them in on time. And then all of a sudden it's midnight and you're like, I haven't done this. Let's see. The Academic Learning Center. I do have a link for that on Moodle. So if we go over here in this first section, we've got our syllabus verification. There's a meet your instructor. You can watch a video of me that's like 2 minutes long. Doesn't really matter as much for us because we're going to be seeing each other weekly. But right here, there's a link to online tutoring. So I don't know if you guys are familiar with the Academic Learning Center or the ALC, but it is a tutoring lab. Used to be in person, now is fully online. You already paid for it. It's in your tuition. So it's free tutoring. If you guys have ever had a tutor before, they can run from $20 to $50 an hour. And this is just there for you. So if you find that you're having difficulty with this class, you need extra help, go to the online tutoring. They're great. I'm not claiming to be the best teacher in the world. I mean, I do the best I can, but not everybody resonates with every teacher. Totally understandable, right? You may have one person that thinks I'm a great teacher, another person says, I do not understand what she's saying. So you may find that some of these online tutors are able to get that information in your brain in a better way than I'm able to. While we're here, there is a periodic table and formula sheet that's useful throughout the semester. You definitely want to have a formula sheet available. So I've got one right here that I use all the time. As soon as you can get one printed out, do so. Oh, I did. Sorry, I'm jumping around here, but I did want to talk about the tests. So all of your tests are going to be online here. The due dates are on the syllabus, and you can see the due dates are embedded in here as well. The test won't open before that window of, usually it's 5 a.m. on the Sunday to 12 o'clock or midnight on the Monday. You have to take it within that window. It won't open before, it won't open after. There is a time limit on these. So for this first test, you have 1 hour and 30 minutes. So you can use your notes, you can use the text, which is helpful. And all those little details that you normally would have to have memorized, you don't have to have memorized. But with that, you do have to still know how to do the stuff. So I have had a couple students last semester get into a pickle where they were like, well, I just sort of assumed that I could teach myself it while the test was happening, right? I don't need to study. I'll just sort of look it up and it'll all make sense, right? 1 hour and 30 minutes is not enough to teach yourself 3 chapters, okay? So go into the test knowing how to do this stuff. Use the fact that you can reference stuff to limit like the memorization. You don't have to have all the elements memorized. You don't have to have all the prefixes for the metric system memorized. But you do know how to, like, you need to be able to do the problems and the equations and things like that. So all the tests are there. Your final is there as well. You get more time for your final 3 hours. These dates may change, but usually they don't. I'm usually pretty good at sticking to the syllabus because it tends to be more pain than it's worth to try and change dates because somebody always misses the date change. So I think the next thing, let's see, we've got our experiments and their due dates. Online homework. So mastering chemistry. This is a step-by-step process on how to get into mastering chemistry. So 3 days from now, when you're trying to do the mastering chemistry and you're like, I don't remember any of that. Well, it is literally 1, 2, 3, 4, 5, all the way out. Okay. So you'll click on this link here and it will bring you to the Mastering Chemistry webpage, where you will have to create a login. If you don't have an access code, this is where it will actually prompt you to buy one. So I've got a code already. Well, I'm an instructor, so I don't really need a code, but yours will look slightly different than this. It'll give you sort of an idea. So, you know, I've got multiples, you'll have one. So this is the code that will get us into our specific class. You don't want to use a different code because it'll bring you to, who knows, Mrs. Smith's class in Missouri. And you want to be in Henderson in Asheville. So the code is sitting right here. The code is also sitting, it's not sitting there. Usually I put it right there. It's on the syllabus. So use this code. So when you click on the course, you get into the course. I do have all the Mastering Chemistry assignments on the syllabus, but they're also embedded in this website. And this one's nice because you can see it in calendar form. And I always like kind of visual things. Lets me know when things are due. It gives me like a spatial spread of my life for the month. So you can see when the assignments are due. They tend to be due, I think all of them really tend to be due on Sunday at midnight. You don't want to start them 20 minutes before. You're going to need, and I'd say about 2 hours for these assignments. So they're all there. Some weeks you may not have something due. So don't get freaked out, just go with what it says. All right, so it looks like on the 14th and the 28th of March, we don't have anything. Looks like on the 14th of February, you also won't have something due. So your first assignment is going to be due on the 17th. This is on chapter 1. We're not actually going to lecture on chapter 1. Chapter 1 is like the chapter where it's like, welcome to chemistry. It's everywhere and everything you do. Okay, so you can read that on your own. I do want you to do the Mastering Chemistry homework. That's going to be sort of just getting you comfortable with Mastering Chemistry. You do need internet access to do it, and you need a computer that has, I think, like some updated Java and all of that. So make sure to get on that sometime this week, and then obviously email me or let me know if you're having issues with that. So you'll follow these steps, plug in this code, and then that should get you to the homework. Those will be due weekly, almost weekly. So make sure you're getting those done. So we start thinking about, okay, what are all the things due every week in this class? You know, you've got your lectures, you've got potential tests, you've got labs, you've got lab quizzes, and you've got homework. There's a couple things due here. The important thing, what everybody always likes to see, is this part of the syllabus, right? This is the like master due date page. So it's broken down by weeks. You can see what we're going to be lecturing on that week. So you may want to look through the chapters before we go over them. Then it'll show you the due dates for laboratory assignments and also for Mastering Chemistry and your tests. So this first experiment measurements isn't due until the following Sunday. So you don't have any labs due this week, but you will have this first Mastering Chemistry due. So make sure you're getting that done. You'll see there's a quiz as well. So I'm giving you reminders, do the lab, do the quiz, do the lab, do the quiz. Also do the Mastering Chemistry. Your first test, just to give yourself an idea of where you're going to be at, Sunday, February 7th to Monday, February 8th. So just under a month, all right, will be your first test, just under 4 weeks. That gives you all the stuff for the whole semester. Again, this could change, but it probably won't. It's just too much work to change stuff. So if you do happen to want to work ahead, or if you've taken this class before and you're like, oh man, I just was awesome with the first 3 weeks, I want to get this out of the way, I have no problem with you turning stuff in early. I won't grade it until everybody else has turned it in, but you can turn stuff in. Do know that we won't be meeting a week from today because it's Martin Luther King Day. So enjoy your time off. We have spring break here as well. Okay. And then I think there is a professional development day somewhere in there, but that doesn't affect us. That's on a Tuesday. So that is the end of the syllabus. Let's switch back over to the Moodle shell just to make sure we've gotten everything, where everything is. So you're starting your tests, which only apply when you have a test, a link to your homework, a login for these Zoom meetings. So you can always find it right here, the lecture videos, the labs, the lab quizzes, and then we have each chapter broken down. These have just additional like little trinkets for you that you can use for studying. So worksheets that may be helpful. Some of them I will use, some of them I won't. We also have an objective sheet here. So if you want help, like what do I really need to know for test 1? This will kind of break that down. And then we have the PowerPoint slides, obviously, which I will be using. I kind of jump between PowerPoint slides and then also an online whiteboard where we do practice problems. And that is, I think that's it. So if you have any questions, go ahead and throw it in the chat. If there's anything I missed or anything that wasn't clear, you don't need to be shy. Or if you're like, I'm not going to type this, you can just unmute yourself and you can just say something too. I'll give it a minute.
On the course registration, there's a lab on Wednesdays. Is that happening or is that like recorded? What's the deal with that?
It will be asynchronous, which means we don't meet during that time. That's just what they have as like the scheduled time, but you will be doing that on your own time. So that will be this section here. You can kind of think of that. And if you've already like blocked it out, let's say you've got a sitter at that time or you're not working at that time, that would be a great time then to work on these labs. Now, during that time, I am around, okay? So if you want to meet and talk about the lab, if you don't know how to do something in the lab, I am totally available for you at that time. We're just not going to formally meet at that time. Does that make sense, Elizabeth?
Okay, yeah, thanks. I didn't know if you were going to break us up into groups to talk.
Yeah, no, you guys have so much already to do like on the computer. We're just going to make that like do as you can do. Let's see. Kayla, you do get the lab manual from the bookstore, and they print it. You don't have to ask them to print it. It'll just already be set. So yeah, you need to get the lab manual from the bookstore.
I'm quarantining right now.
Yay, so am I.
Is it okay if books a little bit later? Like, do we have to get those in person? Because I don't know when I'll be out of my house. I get tested.
Okay. So I would reach out to the bookstore and tell them your situation as far as like you need the text, but you can't be there because you're quarantined, and they will figure out a way to get you your books. Okay. Yeah. Mm-hmm. Other questions? No. Are you guys also excited to do chemistry online? Last semester wasn't too bad. We were able to make it happen. Okay.
Very excited.
Very excited. Look at that. Awesome.
Are our texts or anything due anytime like before midnight? Because I have work during the day.
No, things will really always, like your homework and your quizzes will always be due at midnight.
Okay.
But it doesn't mean like if I have had people say, oh, but I have work and it runs through midnight at that time, then you have to get it done before the due date. Like I've had like quite a few paramedics who are like, well, at that midnight date, I'm working, and I'm like, well, then do it on Friday, do it on Saturday, do it on Monday of the previous week. And you can ask me questions if you don't understand something. So the sooner you get it done, the better. Yeah. Other questions? Okay. So we're going to do a little bit of lecture because why not? Why not? And if you think of any questions while we're lecturing, you can throw it in the chat. So while I'm lecturing, if you have questions, throw it in the chat. It is kind of hard sometimes to lecture and manage the chat at the exact same time. So if you've got a question that's like really relevant and I haven't answered it and it's in the chat, you can just take your mute off and ask. So let's see. So chapter 1, PowerPoint lecture is for you. The text that's for you, I want you to read that. We're going to start at the second chapter, which is all on measurements and problem solving. Okay. So the very, very first thing that we're going to talk about is the uncertainty in measured values. So a measured value is different than like a counted value. If I was to count my students, those are incremental objects, right? 1 student, 2 student, 3 students. You can't get like more precise at counting students. There are these whole entities. But with a measured value, like let's say we were to weigh a student, I could technically weigh a student and get better at weighing if I had a better piece of equipment, right? If I have, let's say, I was weighing a student with this, oh, it's snowing out. Okay. If I was weighing a student with a bathroom scale versus, let's say, I was weighing a student with like a really high-tech scientific scale. There's a certain level of uncertainty when we look at these measured values. So there's an example here where it says the average global temperature has risen by 0.6 degrees Celsius in the last century. This is a measured value. It's a value that they've gotten from actual data. When you report this, what you're saying is that it could be 0.6 plus or minus 0.1 degrees C. So that 0.6 or that value all the way to the right is an uncertain value. It could be as high as 0.7 or as low as 0.5. So just know with your measured values, there's an uncertainty to that last number or the number all the way over to the right. Obviously, the more decimal places you get, your uncertainty value moves farther to the right, you get more precise with your number. So we got to talk about scientific notation. In chemistry, we deal with numbers that are really, really big and or really, really small. And it is very cumbersome to write a very large or very small number in decimal form. So what we will do is we'll shorten it up into this thing called scientific notation. Scientific notation has 2 components. It has a decimal part and it has an exponential part. And it's separated by a times symbol, a multiply symbol. The decimal part here needs to fall between 1 and, I want to say 1 and 10, but it's like 1 and 9.99999. You would never use 10. You would drop it back down to 1. So the decimal, you want it to be between like 1 and 10. The exponential part is going to be a value of 10 raised to some sort of power. And the power, if it's positive, it's talking about a big number. If it's negative, it's talking about a small number. So when I'm looking at this, what I'm seeing is a very, very small number. And I will show you how we can get from the numbers you're used to seeing into this form. Just some things to talk about. 10 to the 0 power is the same thing as 1. 10 to the 1 power is 1 times 10, which is 10. 10 to the 2 power is 100. 10 to the 3 power is 1,000. One way to do this is whatever the exponent is, that's how many zeros you have after the 1 if it's positive, right? So 10 to the 3 will have 1 with 3 zeros. 10 to the 0 will have 1 with 0 zeros. We have our negative exponents. These are different than our positive exponents. When I say 10 to the negative 1, what I'm saying is 1 divided by 10, or 0.10. When I'm saying 10 to the negative 2, I'm saying 1 divided by 100, or 1 divided by 10 times 10, which would be 0.01, so on and so on. So positives, as this number gets bigger, as your exponent gets bigger, your number gets bigger, right? Negatives, as this number gets bigger behind the negative sign, your number will actually start to get tinier. So how do we convert a number into scientific notation? We first want to find the decimal part, and then we talk about finding the exponent. We move the decimal point to obtain a number between 1 and 10. We multiply that number by the decimal part, yada, yada, yada. Let's just do an example. I feel like sometimes it's just easier to see it as an example than talking about this. So this is the whiteboard that I use pretty regularly. Sometimes you might see drawings from my 5-year-old daughter because she sneaks in here and draws pictures on here. Nothing today, though. Right. So let's work with a positive number, or a bigger number for right now. 3, 4, 2, 0, 0, 0. Okay. Now, would I write this in scientific notation? I don't know. I might keep this just as it is, because writing it in scientific notation doesn't really cut that many characters down, but just use it as an example. So where does the decimal live in this number? It's hidden. It's right there, okay? It's at the end of the number. If I was to want to add halves or tenths or hundredths or thousandths, I would add those after the decimal, right? So the decimal is hidden right there. The first thing I need to do is write my decimal portion between 1 and 10. So I want my decimal between 1 and 10. So that means that the decimal needs to move right here. So I'm going to write the decimal part as 3.42. Now, it's not enough for me to just take 342,000 and change it to 3.42 and be like, oh, that's the same thing. I have to show that this is actually a big number, right? I have to preserve the magnitude or the size of it. So that's where the exponent comes into place. I say times 10 to the, and then what do I put as my power? Well, it is how many hops you have to take to get to your new decimal position. So if my decimal sits here, I have to hop 1, 2, 3, 4, 5 hops. So I'm going to put a 5 there. As far as, is it positive and negative? Some teachers will teach it, well, if you're hopping to the left, it's going to be positive. If you're hopping to the right, it's going to be negative. But if you're going the other direction, it reverses. So I don't use that. I just think conceptually, what am I trying to make? Am I trying to represent a small number, or am I trying to represent a big number? In this case, I'm trying to represent a big number, so I need to keep my exponent positive. Positive exponent, big number. Let's try, or I'll have you guys do this one. 6, 0, 1, 0, 0, 0, 0, 0, 0, 0, 0. Ooh, awesome. Have fun with that. Okay, so write that guy out. It's a pain to write out. And so then that's why we're practicing the scientific notation. Much easier to write that in scientific notation. So I'll give you just a minute for that. Okay. And FYI, I have the handwriting of like an 11-year-old boy. So if you ever can't read something, just say, hey, I don't know what that says. Because sometimes they can get a little squirrely. Okay, so this pen has been giving me a hard time. So the decimal is living right here. We want the decimal, hopefully you guys came up with this, wanting the decimal to live right there, right? So the first part is 6.01. If you're wondering, do I have to add all these zeros to the number? We'll talk about that in a little bit. That has to do with significant figures. But we want to get this decimal all the way over here. So I need to take 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. 17 hops. And am I representing a large or a small number? This is a really big number, so we're going to keep that positive. Let's try a let's try a small number. So 0.000000022. Okay. So I don't know, maybe this is like the length of a piece of hair or something in meters. So if we want to convert this from, we call this decimal form, we want to convert it into scientific notation. Find out where the decimal is. It's easier in a small number to see the decimal. It's living right there. We want to put the decimal where we can get a number between 1 and 10. Don't make it bigger than 10. Don't make it smaller than 1. So we wouldn't want it to be 22. We wouldn't want it to be 0.22. We want it to be 2.2. So the first part is 2.2 times 10 to the, I count my hops up. 1, 2, 3, 4, 5, 6, 7, 8 hops. And this is representing a small number. So I'm going to put a negative in there. Again, some teachers will say, oh, well, if you're going to the right, it's a negative. I can't remember right and left on my own hands anyway. So again, I think big number or small number. Let's have you do one of these. So 0.0186. Write that in scientific notation. Okay, so again, this is a number that I don't know, I'd probably want to just write it like this, then write it in scientific notation, but just for the practice. We've got our decimal living here. We do a different color. We want our decimal to live here. So it would be 1.86 times 10 to the, how many hops? 1, 2, 2 hops, and this is a small number. So 1.86 times 10 to the negative 2. How many characters did this first thing have? 1, 2, 3, 4, 5, 6. How many does this have? 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 characters. This is actually more cumbersome to write than this. So that would be, you know, a situation where I'd take either or. Don't write things like this though out. Always make sure those are in scientific notation. Let's pop the slides up, see if there's anything in here useful. Sometimes they're more work than they're worth. So this is just telling us that idea of like hopping over to get us between 1 and 10. You can do it either way for big numbers or for small numbers. Okay, so we'll talk about that in just a minute. Let's try going the other direction. So I want you to write the full decimal form for these scientific notation numbers. 2.84 times 10 to the negative 13. 1.19 times 10 to the 7th. And 3.4 times 10 to the 1. So you go the opposite direction. I want to see if you can try and expand those out. Okay. So I didn't fully tell you how you go in this direction. I wanted you to try it out, but this is how I will go about this. I look at this thing and I see negative 13. That indicates to me this is a small number. I need to be making a tiny number. So I'm going to write this thing somewhere over here, 2.84. Now, in order to undo this, I need to hop the decimal out so that I can get a tiny number. If I start hopping in this direction, it's going to make a big number. If I start hopping in this direction, it will make a small number. How many hops do I need to make? 13 hops. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. I almost ran out of space, and I'm going to put my decimal. What do I have to do with all these empty hops? I need to fill it in with zeros, okay? So 0, Because one of the hops is taken into account by this number, anytime you're making a small number, whatever the exponent is, this is negative 13, it'll have 12 zeros. If it was negative 18, it would have 17 zeros in front of it. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 zeros. Ugh, that's so cumbersome. This number here, this is a big number, right? That 7 is telling me I need to be writing a positive, a big number. So I'm going to write 1.19 over here. And I'm going to move my decimal to the right, or I'm just going to move it in the direction that's going to represent a big number. So 1, 2, 3, 4, 5, 6, 7. And then what I need to do is fill in all of those empty spots with zeros. So 1, 2, 3, 4, 5 zeros there. 1, 2, that's 7. Yep. This one here, okay, 3.4 times 10 to the 1. I have one hop in the big direction. So if it's 3.4, I'm going to hop it over. It's going to become 34. I'd probably just write 34 like this as opposed to this. Questions on that, on hopping, big numbers, small numbers? You can throw it in the chat. You can unmute. Expert scientific notation people at this point. Okay. So just remember negative, small number, positive, big number. For all, kind of already talked about this, but for all measured values, there's a level of uncertainty, and that uncertainty is within the last digit. So the last digit of a number is always estimated. Like if this number was to pop out on a scale in a lab, the scale is estimating the final digit for you. All the digits in front of that last digit are certain values. You know for sure there's a 4 and a 5 and an 8 and a 7. The 2, well, is it 45.873? Is it 45.871? We're not quite sure. This scale or this observer thought 2 was the best bet for it. The greater the precision of the measurement, the greater the number of certain values and or significant figures. So if my scale was even more accurate and I could add and tack on more numbers to this, I'm still only going to have one estimated value, but my certainty goes up. So let's look at this scale here. This is a really this is a crappy scale. Okay, so you're going to get a crappy piece of information out of it. You've got this like suspicious blue substance that you've put on the scale. And here we can see that the tick marks on the scale are for every gram. So it has a tick mark for 1 gram, for 2 grams, for 3 grams. It doesn't have any tenths, hundredths, anything like that. So when measuring this, I know for sure by where the line is that I've passed the 1 gram. I haven't gotten to the 2 gram mark. I've passed the 1 gram. So my 1 is certain, but I'm not exactly on the 1, right? I'm a little bit past it. So I'm going to estimate how far past that I've gone. I'm not all the way to the 2 mark. I'm not even halfway. So this person, or whoever said it's 0.2, right? So it's not just 1, it's 1.2. The 1 is certain. We see the bar. The 0.2 is estimated. You may be looking at this and saying, well, I don't think it's 0.2. I would actually say it's 1.1. That's where that uncertainty comes in. So with equipment, you can always guesstimate 1 past your smallest tick mark. So in this case, your tick marks are at the 1s, so you can guesstimate to the tenths. What if we have something that's a little bit more precise? This gal here, we have this cute little pistachio sitting on it. In this case, we have tick marks for the 1, the 2, the 3, but we also have a series of smaller tick marks for the tenths place. So this pistachio is coming out at, we know we've passed the 1, we haven't gotten to the 2, so we're sure about the 1. Then we can count our little ticks. There's 1 and 2. So we're somewhere between the 2 and the 3, so I know for certain I've passed the 2. I'm not exactly on the 2, so I want to guesstimate somewhere between the 2 and the 3. That's where that 6 comes into play. So it's 1.26 is the estimated value. This number is more precise than this number. I would say that this has 2 significant figures. We'll talk about that in a minute. This guy here has 3 significant figures. What if our scale got better? What if we had an even more precise scale? We can start tacking more certain numbers on the end and we'll have more precision. So a significant figure is a number within a measured value that lets you know how precise the number is. It's not acting as a placeholder. It's not acting as just an indicator of like magnitude, like how big or how small a number it is. It's actually saying something about like how precise the number is. So there are rules for classifying something as a significant figure. These are all the rules. The first thing is all non-zero digits are significant. Okay, so if it's a between 1 and 9, you can say that's a significant number. It's the zeros that are tricky. So going back here, this is a non-zero, this is a non-zero, and this is a non-zero. So I would say this number has 3 significant figures. This thing, both of those are non-zeros. There's only 2 of them though, so this has 2 significant figures. This is less precise than the other one. Interior zeros. So zeros are going to be the thing that throw you off, but interior zeros, zeros between 2 numbers are always significant. So let me show you an example of that one. So if I write a number like this, 101, 101. This number here is significant. This number here is significant. The 0 in the middle, because of rule 2, is also significant. So we would say this has 3 significant figures, or 3 sig figs. You can't have a number that's precise or talking about precision and then all of a sudden stops talking about precision and then restarts talking about precision, right? If you're talking about certainty, it's in a chunk or a unit. So this is significant, this is significant, this is significant. Same thing would be true with a funky number like this, 1 0 0 0 0 0 0 2. This is significant, and all those numbers in between are also significant. So we would have 1 2 3 4 5 6 7 8 sig figs. Pretty precise number here. Because you're not saying this is, I don't even know what this is right now. You're not saying, oh, I don't know, it's like 10 million. It's like 10 million people. You're like, no, it is 10 million and 2 people. Like exactly 10 million and 2 people. Very precise. Let's check out a couple other rules. So trailing zeros. Zeros to the right of a non-zero number that fall after a decimal point are significant. What does that mean? Let's show you an example of the third. So if I have a number like this, 0.0, no, I don't want to do 0.0. We're going to do this 0.3. How many significant figures does this number have? I will tell you right now, just this thing is significant. So this has 1 sig fig. I'm going to write this a little bit different. 0.30. How many significant figures does this have? Well, this 3 is significant. The 0 that comes after the decimal, after the root or the base number. Okay, so if it comes after this thing, we're going to say that's significant. This has 2 sig figs. How are these 2 numbers different? Well, this one you're saying, oh, it's 0.3. I don't know, it's 0.3 to the 10th place. This one you're like, no, it is 0.30 to the 100th place. Like we are right on that. All right, what if I wrote something like this? 0.3000. This is like a super precise number. We're saying 1, 2, 3, 4 sig figs here. Scientists are lazy. They don't want to write numbers they don't have to write. So if they're putting zeros on the tail end here of a decimal, it's to let the reader know that they're very precise with that number, that their piece of equipment is like super, super precise. So it's not enough to just be like, it's 0.3. Like how precise is your 0.3? Are you on a crappy piece of equipment or are you on a really precise piece of equipment? Couple other rules here. Trailing zeros that fall before a decimal point. Trailing zeros that fall before a decimal point are significant. Okay, so this one is kind of weird. Go with it. I'm gonna write two numbers. I'm gonna write 400 like this, and then I'm gonna write 400 with a decimal. Then I'm actually gonna write 400 with a decimal and 2 zeros after it. For this first one, the only significant figure that I can see right now is this 4. This has 1 sig fig. And we'll talk about, actually, this is ambiguous. Like, I don't know what's happening with those zeros, but really I can only honor 1 sig fig. This one here, sorry, I think the pen keeps popping up. The second one here, it's not just saying, oh, I'm like 400, guesstimating 400. It is saying you're exactly 400. When you put that little decimal in there, you're letting the reader know that your precision is to the ones place, that you know for a fact it's exactly 400. The last one there is gone even a step further. It's combining this rule with the rule before. So in this rule, we know that the zeros that come in front of a decimal are significant. So the 4 is significant, the 0 and the 0 is significant. And then we know that zeros that come after the decimal, after the base number, are also significant. So this has 1, 2, 3, 4, 5 sig figs. Let me write this. This has 3 sig figs. You guys seeing how this is getting sort of more precise? Like, this number looks a little loosey-goosey. Like, what do you mean 400? Like, did you measure that on your like kitchen scale? Or no, it's 400 to the hundredths place. This is like really precise. We did this in a lab setting. Some other kooky rules. Leading zeros. Anytime there's a zero, there's zeros in front of the base number, they are not significant. They're only there to tell you where the decimal is. So this really only applies to decimal numbers or small numbers. But when I write something like this, 0.002105, where is the base number or the actual number? It's this thing here. These zeros are only there to let you know how big or small the number is. So this is, you know, hopped over to the thousandths place. These zeros aren't significant. This is significant because of rule 1. This is significant because of rule 1. This is significant because of rule 1. This thing is significant because of rule 2 or internal zeros. So this has 4 sig figs. If you're wondering, well, why wouldn't you consider those significant? Okay, well, let's say that this number 0.002105 is talking about kilometers. And I want to convert this into meters. I don't want it in kilometers. I want to keep it in meters. Well, in order to do that, and I will teach you guys this later, you hop the decimal over 3, 1, 2, 3. So it's 2.105 meters. Do I put the zeros in front there? No, those don't need, you don't need those anymore because you're not needing them as a placeholder. So we don't need any of that. Precision happens by adding things to the tail end of the number, not in front of the number. What else we got before we go today? Trailing zeros at the end of a number but before an implied decimal point are ambiguous and should be avoided at all costs. Okay, this was that 400 situation that we just talked about. So if I write the same number, but I really just change that inferred decimal, it changes its meaning. So say I have 3 million, like this. I don't know, as a reader, I don't know, like, how precise is it? Just the only thing I know that's significant really is this 3. Those zeros don't have any significance. But if I was to write this number like this and put a decimal there, you know, this is, let's say we're talking about marbles. Okay, and this one, 3 million marbles, like maybe it's 3,200,000, maybe it's 299 or, you know, 2.99 million. Here with the decimal, I know for a fact that there are exactly 3 million marbles. Okay, so this first number here has one significant figure, or sometimes it's referred to as ambiguous. This here has 1, 2, 3, 4, 5, 6, 7 significant figures. This is very precise, or more precise. Any questions on that? We'll do a little bit more practice next time. I'll just give you some numbers and ask you guys to tell me how many sig figs. But any questions on those rules while it's still fresh in your mind? Okay, awesome. So next time, I will probably break you guys up into breakout rooms just for a minute or two so you can get an email from somebody else in the class, and in case you missed something. But that's kind of how it's going to go. So feel free to stay around if you have any specific one-on-one questions. I can put other people in the waiting room and we can talk individually. Otherwise, good luck with your first week, and I will see you all on Wednesday. Bye-bye, guys.
Hey, Professor, I had a question. This is
Yeah.
Chris.
Yeah, what's up?
So you did say that you record these lectures. Is that going to be also be found on Moodle?
Yeah, here, let me share the screen again. I'll show you exactly where it is so there's no confusion. So do you see, can you see my screen?
Yes, I can.
Okay, so you see here where it says login, that's for our Zoom meetings. And then this here where it says lecture videos, that will transport you to the YouTube channel where the videos will be posted by the end of the week.
Okay, perfect. Thank you.
Okay.
I'm sitting in the airport trying to do all these equations, but it's
Okay.
not working. So
Okay. Okay.
cool. Thank you.
Mm-hmm. Okay, so people who are still hanging around, I'm gonna put you in the waiting room and then bring you in one at a time, just so you can talk. Oh, looks like only one who's left is Sarah. Sarah, do you have a question?